Good evening, good morning, and good afternoon. Thank you all for joining today's webinar on AI in China's digital water applications and strategic insights. This is organized by the China subgroup of the IWA Digital Water Program and with the Chinese media partner, 水务家 Company. Welcome. Before we start, I will share some housekeeping rules. This webinar will be recorded and made available on the demand on the IWA Connect Plus platform that is for IWA members. And the speakers are responsible for securing copyright permissions for any work they will present of which they are not the legal copyright holder. The opinions, hypotheses, conclusions, or recommendations contained in the presentations and other materials are the sole responsibility of the speakers and don't necessarily reflect IWA opinions. And for this webinar, please use the chat box only for general requests or for interactive activities. And if you have any questions, please send into the Q&A box, and please refer to the speaker you want to ask questions for. Okay, welcome to today's webinar. And I will introduce the webinar chair, the moderator, Dr. Yufeng Guo, who is the co-chair of China subgroup of IWA Digital Water Program, and he's also the Deputy General Manager for the Three Gorges Smart Water Technologies Company. Dr. Guo, please.
Thank you, Dr. Li. Hello, everyone. Welcome to the webinar. I'm Yufeng. Before we begin today's presentations, let me briefly introduce the IWA Digital Water Program China subgroup. The subgroup was established in June 2023. It brings together experts from leading water utilities technology companies and research institutes dedicated to advancing the digital transformation of China water sector. Currently, we have 33 members on board. Our core missions is built around three key functions: a platform for collaborations, a bridge to the global community, a hub for knowledge and experience sharing. Today's webinar features industry leaders and technologists, experts from Baidu, Beijing Capital Eco Protection Group, and Macau Water. Then I will introduce the webinar agenda. Start with the five minutes of introduction. Then we'll have 3 presentations. For each of the presentations will last for 20 minutes. Then we will have a panel discussions. We are honored to host this special expert panel featuring Professor Dragan Savage, a world-renowned expert in hydrodynamics. The panel discussion will last for 30 minutes. The final section is a final 5 minutes closing. Okay, let's start the webinar. The first speaker is Dr. Qiuwen Wang. She is head of smart water industry of Baidu Artificial Intelligence Cloud. She is also senior AI large language model engineer. Dr. Wang holds a PhD in smart water and leads over 20 major smart water projects at Baidu AI Cloud. She pioneered China's first multimodal CV-driven municipal inspection group standard and the country's first water large language model white paper, and can contribute to the ISO smart water guidelines. Okay, Dr. Wang.
Okay, wait for a moment. Sorry, it looks like it doesn't work for my computer now. Wait for a moment. Is that okay? Can I start?
Yes,
Yes,
please.
yes, you can start.
Okay. Hello, everyone. Good day. I'm Wang Chuwan from Baidu AI Cloud Group. It's my great honor to be here today to share with you how AI is advancing water and environmental sustainability. Our journey today will explore Baidu case study, technical insights, and future exploration. My presentation today is structured into 4 key parts. The first one is water and environmental management challenges, strategy, and solution. And second part, it is Baidu water and environmental technical deep dive.
Sorry, Dr. Wan, could you share your window or share your desktop, not the windows, please?
Okay, it looks like
Yes.
I will double sorry. Is that work?
Yeah, it's okay now.
Yes,
Please
that's
Does that
go on.
work?
Yeah.
Okay. So continue. My agenda is instructed into 4 key parts. The first one, it is the challenging and strategic solution. Second part, it is Baidu technical deep dive in water industrial. And third part, it is Baidu case study for the real world impacts. And the fourth part is the future exploration and conclusion. So for the first parts, nowadays, and as all we know in the water industry, we know that the world faces unprecedented water challenges. Water scarcity affects over 2 billion people, and flood and waterlogging cause immense damage. The water supply chain is fragmented, and infrastructure is aging. So now this is where AI steps in. AI can transform fragmented data into actionable insights, enabling autonomous decision-making and driving efficiency and sustainability in water resource management. To address these challenges, Baidu provides a full-stack solutions with our chip-to-agents architecture. This integrated AI-native infrastructure consists of 4 layers. Starting from the foundation chip, we build up through clouds, we call it ICE, and model we call PaaS, and finally to AI agents we call SaaS. This stack provides a comprehensive and sustainable solution for water management. And for the second part, we talk about the evolution of AI from chatbot to autonomous agent. As all we know that the AI agents evolved very quickly in the past 3 years. The evolution of AI has been remarkable. We've been moved from traditional chatbots to autonomous agent. This shift is not just a tool upgrade, but a change in our relations with the water system, with the technology. AI agents are intelligent collaborators that can understand, plan, and act in our real world. In the water industry, their ability to break down tasks, code tools, and learn, which makes them uniquely suited for dynamic and complex water system. Let's dive into the technical details. The multi-agent collaborative architecture, it looks like a complex, but there are 5 key components. The first one, it is agent builder. This agent builder is the backbone. Agent builder is for defining capability, and model management for handling diverse models, and tool calling and skill integration for interacting with the physical world, memory and state management for learning, and multi-agent collaboration framework just for teamwork, for the cooperations. As to the technical deep dive, we have the second part for that is agent infra application. We have many kind of advantages inside. The application advantage of agent infra are significantly. It transforms static knowledge into dynamic productivity. Our capability is upgraded from a simple Q&A to the complex text execution. And the AI agent is not only a chatbot, it's execution tools. The practical effectiveness is proven. Application efficiency is increased by more than 1 times, and the resource utilization is improved by 3 times. This architecture is the engine for the intelligent transformation of the water industry. And now let's look into the further layer. We now can face the AI agent. We call it self-evaluated agent. We call FAMO, which is adapted dynamic algorithm fusion. As we can see in this slide, the FAMO agent, its core principle is very simple. The scenario defines what needs to be done, and the large language model defines how to do it. And this is achieved through a cycle of interaction from a sampling, assembly, a generation, and evaluation. This architecture consists of 4 key parts. We call context assembly, strategy, algorithm generate agents. We can use the coding agents from here. And last one, it is evaluator, always say that simulation, which forming a closed loop system. And this FAMO agent, how to apply it in the water system, we have 2 phases. And the first one, the first layer is the core agent infrastructure, including CoStar for knowledge injection and self-involving flyway mechanism for continuous learning. It means we have the basic water knowledge inside and can understand the scenarios. And the second part, it is self-involving flyway, which is rail distributed cluster. The application layer translates this capability into tangible solutions like intelligent dispatch, predictive maintenance, pollution tracking, and proactive support. So let's come to the case study. We have several cases just from the water conservancy engineering and to the water management in our urban city. And this is the case study, the case 1. Our first case is Tianjin Water Conservancy Engineering Safety Management Agents. And these agents, this project leveraged Baidu's Baidu's Qianfan platform, which called a PaaS, to build a leading water conservancy and safety agents. Its core capability include intelligent interpretation, professional response, human-like interaction, and situation awareness. The results in these agents are impressive, supporting over 50 business knowledge scenarios and improve efficiency by more than 85%. And our second case is focused on the urban water bottler agents, which is cooperate with the Shenzhen Environment Group. This agent addresses services, gaps, and inconsistent quality. The application result shows multi-level empowerment. Just for user, it acts as 24 to 7 days butler. For service staff, it's an instant answer database. And for managers, it's a decision-making advisor. This truly empower water and user services. And come to this case, and this is for waterworks, or we say the water treatment plant. This is covered for full process optimization, which is in Guangzhou, Huadu waterworks plants. And this case is, we call it an agent, address services, and this cases, it is the China's first large water treatment plant optimized by large models and connected with the small model we call the data models. The historic challenges are high energy and consumption and unstable operation. The AI agent's intervention led to significant effectiveness, reducing chemical consumptions by 50%, cutting energy cost by 5%, and improve operation stability. And this is another case. For the Longtan hydropower station. We use AI to do some water region prediction. In these cases where we applied AI for water region prediction, the technology involved extracting 15 key features and using a directional LSTM transform hybrid model. The results were stunning. 100 times faster response speed, and accuracy efficient ratio of 0.96 notch data. And for the 7 days prediction lead time, demonstrate the critical value of AI in safeguarding lakes and property during natural disaster. And come to the fourth parts, we talk about the future exploration. Looking to the future, we envision a shift from single point intelligence to the a global autonomous decision making. The core hub for water conservancy or waterworks large models will not just the single point tools, but the core hub that connects cross business scenarios like small flood prevention, water treatment, wastewater treatment, and eco-environment monitoring, etc. This vision represents the ultimate goal of AI in water management. And the AI represents a fundamental mode change for the entire sector. The paradigm shift is redefining the water industrial production relation. We are moving from a human experience-driven model to data and foundation model-driven decision system. The ultimate value is completing the historic shift from passively reacting to water disaster to proactive planning and autonomously dispatching resources. So to conclude, the global water industry is at a critical inflection point. We have a window of opportunities with a vast user base and a growing development community, as you can see the figures on the slide. And we say the closing thought is that together through the openness, co-creation, and mutual access, we can build a future of sustainable water together. Thank you for all.
Okay, thank you, Dr. Wang, for that insightful overview of Baidu's AI toolkit and how it's being deployed in real-world water scenarios. Thank you very much again for these interesting presentations. Okay, next we turn to smart operation in the water and environment protection industries. Our speaker is Mr. Ruozhu Shen. Ruozhu is Deputy General Manager of Smart Environment Protection Division, Beijing Capital Eco Protection Group. She is also a member of the China subgroup of the IWA Digital Water Program. Ms. Shen drives research and intelligent practice on integrated urban water systems management at Beijing Capital Eco Protection Group. Her team has earned 15 Science and Technology Awards and continues to define operational benchmarks for China smart water utilities. Ms. Shen, your turn.
My topic is exploration of smart operations in the water environmental protection industry. My sharing is divided into 3 parts. First, let's review the current states and challenges of our industry. The urban water system is a complex system where natural water and social water are coupled together. If we carefully observe the system, we'll find that assets within it have the following characteristics. They are widely distributed in space, large in number, and diverse in type. Besides, these assets are strongly correlated, have indistant boundaries, and their performance outputs are consistent. How to maintain water environment quality over the long term has now become a new challenge for us, since our industry mainly relies on government payments and lacks a pay-for-performance mechanism, and we often don't invest enough in operation. That leads to some tough challenges and pain points, like not really knowing our asset base, having pretty rough operation methods, relying too much on individual experience, and struggling to scale what works. On the flip side, with many governing bodies and low market concentration, data standards are all over the place, and we can really leverage the huge volume of data available. So there's an urgent need to build a smart operation system for urban water system that couples business flows and data flows from the heart of urban water system operation is asset management. Since 2019, our team proposed the concept of water environment asset management. We believe that all kinds of facilities, equipment, and ecosystems should be managed collaboratively. Only by doing so, we can achieve both economic and environmental values. Even though urban water systems are complex and every project has its own unique features, every industry has some common ground and underlying logic. By repeatedly analyzing and reasoning through various business scenarios, we develop a smart management method that covers the entire life cycle of water environment assets. To put it simply, operation is really about knowing what assets you are managing, what condition they are in, what standard maintenance task they need, and going one step further, how to coordinate and dispatch them. During the implementation, we focus to core threads, business flows, and data flows. We map our business logic based on real operational scenarios and re-engineer the business process for the digital world. That's how we shift from traditional people-driven operations to data-driven smart operation. Furthermore, we developed the WIN platform, which is microservice and multi-tenant architecture and featuring core functions including asset management, operations and maintenance management, monitoring center, scheduling center, business control, and so on. On the asset management side, we've built a data standard system and data collection and verification specifications that cover all the categories and multiple levels of urban water system assets, involving 937 asset types. This ensures that assets data is entered into the database with high quality. In addition, we've established a set evaluation methods and standards based on condition diagnosis and risk assessment, which supports tighter operation. Previously, we relied heavily on the manual methods for information recording. Nowadays, through the establishment of classification and coding rules, the optimization of the collection process, and the integration of the emerging technology like rapid spatial positioning, multi-source data fusion, automatic data verification, and real-time interaction, we have achieved a remarkable increase in asset inventory efficiency, surpassing from 4 assets per person per day to 20 assets per person per day, thereby building a appreciate and accurate database. Using this database, we can check the current state of each facility and equipment, focusing on aspects like structure, functionality, and efficiency. Then we are able to evaluate the likelihood and consequence of the potential risk. Based on these findings among all the assets, we can decide which one is more important and needs our attention first. And we can also take proactive action to prevent problems before they occur. On the operational technical standard side, we apply a methodology of identify, deconstruct, reshape, and standardize. This helps us build a technical standard system covering 17 sectors of the water environment and the entire workflows and over 100 operation scenarios. It solved the long-standing problems of traditional operation technical standards, namely long structuralization and difficult integrating with information technology. Take the Huai'an's project as an example. Through the operation and maintenance management system, we integrate 45 operation scenarios, 90,000 operation record standards, and nearly 24 criteria. This standardized improve service quality. In addition, the system's business visualization and data analysis capabilities significantly reduce the workload of the incident handling, operation recording, document management, and other tasks, greatly improve the management efficiency. On the monitoring and analysis side, we combine the operation needs of the urban water system project to build a standard prototype library for the IoT devices and the library of monitoring indicators. This helps ensure that monitoring data can be used efficiently. At the same time, we use the data warehouse to analyze the monitoring data, forming a multi-sector, multi-indicator, multi-sim monitoring and analysis technical system that puts data at the core. This approach breaks down the technical boundaries between monitoring hardware, software, and data. In the Huai'an's project, we achieve full monitoring coverage across all sectors, plants, networks, and rivers. We've connected over 650 devices and generated 380,000 new data records every day. This allows us to dynamically monitor the environmental benefits of the project operations. On the multi-objective scheduling side, we've established multi-objective coordination rules and built a built-in route engine. This can handle various dispatching scenarios, such as urban flooding, water system connectivity, and water circulation scheduling by integrating simulation, equipment automation, intelligent algorithm, and dispatching tasks. We solve the common problems of inaccurate, hard to quantify, and untimely dispatching. Take the Huai'an's project as an example, based on the real-time monitoring data and over-the-limit alert from the monitoring center, plus hydrodynamic and water quality models, administrator can make scheduling plans and correct decisions during emergencies. This approach shifts the traditional emergency response mode to a comprehensive water system scheduling mode, achieve response time of less than 1 minute, and cutting execution time by 30%. To make the platform easier to irritate, scale, and promote, we adopt a loosely coupled, independently deploying microservice architecture. Both business standards and data standards can be freely figured. It showcases features like a modular combination, flexible splicing capabilities, and broad adaptability to diverse asset types. This intelligent platform is designed to be freely customized to cater to the specific requirements of various business. As we can see, it acts like the business middle platform. Since its official launch in 2023, the WIN platform has been successfully deployed in over 20 projects across various locations, managing assets exceeding RMB 90 billion and supporting more than 500 users. Over 1,500 IoT devices have been integrated with the platform, resulting in a daily incremental data volume of 3.3 million. Notably, it helps the administrator achieve 100% compliance and assessment, enhance efficiency by 15 to 20%, and realize cost savings of 10 to 15%. It has also accumulated a huge amount of data, which lays the foundation for AI applications. The final part is about activation, integrating business with data and empowering through AI. In our industry, data comes from a really wide range of sources, and there are many different data types too, including assets data, operational process data, sensor data, geographic information data, and so on. As AI technology keeps advancing, it can bring improvements in both efficiency and effectiveness to our many scenarios in urban water system, but our industry is public service oriented and with limited profit. It's not realistic to expect governments and companies to go all in on AI. So choosing highly cost-effective scenarios becomes really important. It helps boost confidence. One of the scenarios we chosen is video-based intelligent recognition for water environment. We picked this for two reasons. First, across 9 of our projects, we've installed 1,252 cameras covering 6 types of the scenarios, so the coverage is very broad. Second, with the development of large vision models, compared to traditional deep learning, they offer huge advantages in cost, effectiveness, recognition accuracy, scenario adaptability, and resources investment. As I just mentioned, most of those cameras have very low intelligence, and the industry standard deep learning approach isn't very cost effective. So we use large version model technology, combining a small amount of high quality golden data with promote engineering and deploy on the WIN platform. That turn those ordinary cameras into intelligent ones with pretty high recognition accuracy. And they can now identify the things like trash in rivers, abnormal discharge at outfalls, and flood roads. When these cameras spot a problem, they generate an alert in the system, and the system then dispatch a maintenance work order, creating a closed loop for identifying the issue to actually solving it. Originally, our system already had weather data, online monitoring data, and on-site report data, now combined with AI-powered alerts. We've greatly improved how quickly we detect and handle problems. Traditional manual patrol used to take 2 to 4 hours. Now it's down to just 3 to 5 minutes a 98% efficiency boost, and the average incident handling time has dropped from 8 hours to 2.5 hours, a 68.75% improvement. Similarly, our investment has been extremely cost-effective. AI applications have lowered the barrier to development. No more massive amounts of annotation and algorithm coding. Total human effort went from 60% per month stress to 4.5% per month. On top of that, because large model recognition supports faster validation across more scenarios, the recognition results are actually better than traditional methods. In the future, we will continue to focus on the standardized and refined operation needs of urban water system, aiming for full process controlled and collaborative governance by integrating 3 key elements: expert experience, data models, the mechanical models. We will explore industry applications of AI. We aim to ensure build a multimodal data integration capability for urban water system and truly promote high quality development in our industry. That's my humble sharing for today. Thank you all.
Thank you, Ms. Sim, for sharing practical examples and the challenges of implementing digital water and AI technologies at scales in environmental operations. That's really impressive. Okay, next presentation will be from Jackie Lee. Jackie is the Deputy General Manager of Macau Water. He is oversees Macau Water's smart water and AI deployment, bridging international engineering practice with Greater Bay Area's digital water transformation. He also serves on the Macau Environment Consultative Committee and the IWA Water Loss China Specialist Groups and Management Committee. Jackie, your turn.
Thank you.
Welcome.
Thank you, Dr. Kok. Can you hear? Can you see my PowerPoint?
Yes.
Yes, Jack. Yes.
All right.
Please go
Thank you very
ahead.
much. Thank you very much. Hi, everybody. I'm Jackie Lee from Macau Water. I'm very happy to be here to present you my topic. My topic today is digital transformations in water management. I will use Macau Water as a use case for smart water applications and some AI use cases. And I will spend about 20 minutes for these presentations. So the content, first of all, I will generally introduce about Macau Water. And I think not many of you know where is Macau. Macau is very small, huh? And how we do the digital transformations for Macau Water. And based on the digital transformation, how we can implement some smart water applications. And from recent year, we're towards some AI applications. It's not many. We're just the beginning of using the AI applications. And finally, I will be present you very short conclusions about these presentations. So Macau is very famous small city. Macau is a special administration region of China. It's like Hong Kong, but we are very small. We only 33.3 square kilometer. It's just as large as Shanghai airport. We are very small, yeah. But we have lots of people. Our population is 687,000 people in such a small area, but we are a lot of people, populations. The treatment capacity is 520 MLD. Network is not long, 750 kilometers. The average daily supply is 280. We have a lot of customers. We have more than 206,000 customers. The NRW ratio is a bit good. We have below 8% of our NRW. And so we have 4 treatment plants, all up to together we have 520 MLD. So although it's very small area, but we still have 4 treatment. And digital transformations. I think the evolution of smart water has come from the rationalizations. Everything, I mean, the process or everything, I think is from the rationalization. And then through standardizations and documentations. And after that, I think the most important, I mean, the base for smart water is the digitalizations. Based on the digitalizations, we promote or we make a bit forward for automations and modeling, and we can become smart water. And then, I mean, the ultimate is the AI applications. But I think we have to do it step by step, one by one. Yeah. And for Macau Water, we have been focused for digitizations for the past 10 years. Just 10 years ago, we try our best to digitalize all our informations, our data, all of our workforce, process for digitalizations. And then based on that, we did practically have some applications for smart water tools. And we do the smart water is not just for fun. We have, depending on 4 objectives, for being smart water, doing the smart water. First is the cost optimizations, and then increase our efficiency, our work efficiency, and then to increase the customer satisfaction, and to more and reliable, the emergency responses. This is our main objectives for being smart water applications, implementations. So here is our 3 pillars of smart water applications. The first one is smart operations, and then smart distributions, and then smart services. So in smart operations, we try our best to be fully automatics. For our treatment works to be more full automatics. And for asset management, we also develop some smart tools for asset management. Water treatment plant, we have a lot of tools, not tools, equipments and assets. So we promote quite a lot, for the asset management and alarm system, because as we are doing the water operations, we know that it generates tons of alarms from the SCADA. So what can we do? We develop something which is very useful for us. For this alarm system, for smart alarm system. For the smart distributions, we're focusing on the hydraulic model applications and the NRW managements. We develop a lot of platform analysis platform, trying to better manage our low revenue water. And smart surface, based on some surface application apps, small apps, which integrate with the mobile phone, and also promote some AMI, the meter reading, automatic meter reading. But I have to emphasize that for every, smart applications, must base on the digitalizations. The digitalization is most fundamental and more critical for any smart applications. Okay, this is a digital visualization platform. We build it from the all data or all digital workflow. We got it from all the operational activities. You will see that I made trying to use a pointer. From the raw water up to our treatment plant, and to water supply, and to quality, asset management, chemical dosage, energy report, and even up to the carbon dioxide emissions report, water consumption. They are all digitalized. Those data update automatically. And I can show you this is focused on the NRW, our report. NRW, follow the 4 pillars. I mean, asset management, pressure management, proactive leak detections, planning, and leak case quality and efficiency. Those 4 pillars, we all have accordingly those report, or I mean the BI. What we use is the BI. This is our minimum life flow. I mean the DMA minimum life flow report, and the data are update automatically. And this is our leak detection summary. And this is the visualization platform. And for the smart operations, we, as I just mentioned, we do our best trying to do the fully automatics. Now we have 4 treatment plants, but all the treatment plants, we are unmanned treatment plants. It's all automatic. They're just based on the one central control room. We have people there. They do something like a pilot or something like co-pilot things. But everything, I mean, for the treatment, and here you see this SCADA. It's not only for the water treatment, but also for the distributions, the pumps, high elevate tanks, some control valves, some sensors. I mean, for the pressure, for the flow, they are real time, and they can be automatically. I mean, for one thing. I mean, for the treatment and distributions, and based on that, we also developed something like a smart chemical dosing. This is based on some sensor, a quality sensor, and of course, it really depending on our automations, and based on those quality sensors, and they adjust the chemical dosage accordingly. And so you see that here we have a icon here is the smart dosing. And we also implement the BIM applications. The BIM application, I think most of you may understood about the usage of the BIM, which is for building or constructions or design of treatment or of a project. This is our newly built treatment plant. We use this for constructions and design, but I will show you it's not only for such usage. I mean, it's not only for the construction or design, but we are using for this purpose. This is for the asset management. This is we used a iPad or any pad, and we use the BIM to integrate with the AR applications, augmented reality, and you can see the networks. I mean the pipes, and also the equipments underneath, under the ground, and every equipment or every facility, you can see the detail, and this is very useful. We found out that for our asset management, our maintenance guy, they need not to draw or use the AutoCAD, the diagram. They can just use their pad, and then it's very easy and very clear to show you the networks or the equipments. We also use that for our distributions. This is our networks in the street. You will see that we use the pad or even our phone, our mobile phone, and we know where the networks are, and we also know their attribute. For example, this valve, how large is the diameter, and what's the pipes material, etc., etc. This is for the smart distributions. I mean, for the networks. And for the hydraulic model, we built a distribution hydraulic model, and which is based on, as just I mentioned, for digitalizations and become modeling. We build a model, and now is we have a real-time hydraulic model, so that is smart applications. And what we are using, I mean, Macau Water using the hydraulic model for what purpose? This is dynamic hydraulic models, and we use the dynamic hydraulic models for optimize our dispatching. I mean, how can we optimize our water distributions through our water treatment plants and optimize our pressure management? It's because we know through the hydraulic model, we know we simulate every load, the pressures, variations, and the flow and the velocity of the water. I mean, through every individual pipes networks. And as this hydraulic model, we are built it, including the pumping station, every pumps we are including in our hydraulic model. So that's why we can also use this dynamic hydraulic model for optimize the energies. Because as you may aware that the water demand throughout 24 hours, there are different. I mean the patterns. During the midnight, they are very low demand. During the daytime, they have two peak demand. So how can we use the pumps to optimize the pressures and energy? I mean, this hydraulic model helps a lot. And based on the hydraulic model, we also built a network quality model. The network quality, what I mean is for residual chlorine, because as a hydraulic model already provides you some very important information, for example, the age of the water inside individual pipes. So based on that, and based on our water qualities assessment for the residual chlorine, I mean the chlorine decay rate, so we can put those data into the model and trying to simulate the residual chlorine's decay simulations. And this is very good for I mean the distribution water quality management, because we know where always, I mean the residual chlorine, which is always very low, and then we try our best trying to adjust some valves or adjust our distributions mode, trying to make the water I mean to turn over more frequently. So this is also a very good tools, I mean, for networks management. And for smart customer service, what we doing, because I think this is we create small apps. This is I mean in our integrate with the WeChat applications, and this is my service. I mean my portal. And you will know that we have a lot of services there. For example, we can change of our mailing address, paying our water bill, and even we can do something like a new meter installations, termination of water or water supply, something like this, which you can very easily using your mobile. I think this is not something really advanced, but yes, I mean it's also very convenient to our customer. And based on that, we also developed this is inside boundary water quality model. This is a high-rise building, about 30 storage building, and we use the AMI, I mean the automatic meter data. We note every hour the water consumptions for individual customer, and so if we do some assessment for the water tanks inside the boundary, I mean inside the property, and we can simulate, I mean use the hydraulic model to simulate what is the water quality. What I mean water quality is the residual chlorine, yeah, the residual chlorine, the situations or patterns inside our property. But what's that for? I mean, why we need to understand this, because in certain cases in Macau, some newly built building, for example, in such a high-rise building, the occupancy rate at the beginning is not very full. Sometimes maybe just 20% or 30% of the occupancy rate. So if the turnover of the water tank is too slow, it will have something like water quality issues. For example, the bacteria grow, something like this. So we have to simulate such behavior or such situations in order to manage well. I mean, about this type of inside boundary quality issues. And move forward a bit for the AI applications. We didn't really have many AI applications, I mean, for Macau Water, but for past few years, we are focused more for the visualization, I mean, the AI visualizations applications. As I just mentioned, our treatment plants are all unmanned, no people at all. It's only security in our water treatment plants. So we used to have CCTV, I mean, for our very critical equipment rooms, like pumping stations and chemical dosage room. But before, we just depending on our central control rooms people, they have to keep an eye on those CCTV. But nowadays, because of the AI, I mean, applications, we can get use of this. I mean, for the AI CCTV platform analysis, and we also use the CCTV for our water treatment improvement. For example, this is coagulations optimization. We put a CCTV very high density, very high resolutions CCTV inside our settling tanks, and to see this is the flock. You see that is the flock, the formation of flock. There's a real time. We trying to capture those data to see, depending according to the dosage rate, what's the formations of the flock inside our settling tanks. And then if we have enough data, we have practicing this project for more than 1 year, and we have captured a lot of pictures. And nowadays we have already put it in our SCADA operations, so it assists our smart chemical dosage applications for that one. And the other one is air flotations. Because for the air flotation, we have to do the backwash in a certain period of time. And before, we just depending on the quality and depending on the time schedule to do the backwash. And nowadays we have the CCTV, we can capture some data from that. I can give you an example for this. What we call is called Visual AI platform. We have captured a lot of data, and we understand this is clean enough. And in such situation, it's not clean enough. So when we have a lot of such image, it can help us to determine which is clean. I mean, in what situation is which the backwash is clean enough, and what situation which is not clean enough. And it's also help us, I mean, for the optimization of our process, of our backwash process. And it helps us to save a lot of water, I can say, and to be more, I mean, reliable, I mean, the water quality for this backwash process. And the other ones we are using, this is the how we practice our visual AI platform. Because as I just mentioned, that for those CCTV image, we have to learn, and then we have to store in large enough data before putting into our operation, I mean our SCADA operations. So we use such a process. We got the data from the VAP platform, what we call the Visual AI platform, and then we put it into our enterprise application platform. We store the data, and we try to export those data into our Fire BI, BI applications, and we learn it to see if it is mature or reliable enough before we put it into our SCADA system. So this is our process, what we have been done for our treatment optimizations. And for the chat BI, because as I just mentioned, we have built integrate visualization data platform, but although we have those platform, we have those Power BI platform, but we have to, depending on our staff trying to analysis the data or the curve, or what we can do. I mean, for the limitation, we just can set some alarm or set some very simple algorithm to trigger some early warning. But what we want to do is, because of the AI, I mean the large language model is already very mature. So we would like to, based on those model, and then to define, we have to define, I mean, the patterns or the criteria of our data, I mean the data set. And then we can get use of those model and trying to use it to see if we can just type in some keywords or some wording, and then the machine can, I mean the AI can cross different data, cross different diagram, graph, and present us meaningful result or data. And this is we are trying to do something like this. It's not finished yet, but I think soon we will get this result, I mean, for Macau Water. And I think that's all for my introduction of that. And finally, I have a little conclusion about that. The Macau Water digital transformations, we make a very clear step. I mean, step by step, and now we are towards smart, efficient, and data-driven water management. Depending on the digitalizations, we move to smart water applications, and now we've been moving to AI applications. Although it's not many applications have been done, but we are moving in these directions. And by applying smart tools, we can improve our treatment operations, network management, and energy efficiency and customer service. And as I just mentioned, I think we will continue to integrate of our smart water applications based on that, and to see what will happen, I mean, in the future about the AI development. And because as we are a private company, so the cost for us is very critical. So, and we found out that some applications of AI is still very expensive. So what we trying to do is we have to learn something, I mean, for ourselves, and then waiting for the more mature, I mean, of the AI application, and then we can use it in the future. Yeah, I think that's it for my presentations. Thank you very much.
Thank you very much, Jackie. It's inspiring to see how Macau Water has turned data and models into actionable intelligence, especially for automatic management, being together with VI models and quality modeling analysis for property. That's really impressive and interesting. Thank you very much. Okay. Hello everyone. That's all for the presentation today. Now we move to the next section. That's the expert discussion panel. Yeah, it's our honor to have Professor Dragan Savage, as I mentioned. Professor Dragan Savage is a professor of hydroinformatics at the University of Exeter and a global advisor on digital science and CEO emeritus of at KWR Water Research Institute. Professor Savage has decades of experience in smart water systems, artificial intelligence, and digital twins. Okay, let's move to these sections. And I also hand over the moderator's position to Dr. Li Hong. Dr. Li, your turn.
Yeah, thank you very much, Yifeng. Thanks to all the speakers for the very excellent presentations. I'm also a new learner today, very much appreciated. Professor Dragan Savage, welcome. It's a great honor to have you here. And I will now stop sharing the screen, and then I would like to ask you, Professor Savage, somehow to share some of your global perspectives. What are the most promising AI applications in water today, and where do you see the biggest hurdles? For all the speakers, could you please share your videos as well? Thank you. Professor Dragan Savage, yeah, your turn.
Thank you, Dr. Li. Thank you for the invitation. First of all, it's a pleasure to be with all you today. First of all, I have to say that I enjoyed the presentations today. All three speakers presented different perspectives, from organizations like Baidu, and we all know what they're well known for, the search engine, but also they do quite a lot of stuff on AI. And then what Roju presented, it's very nice selection of case studies. Asset management is something that we see in every branch of water management, all sorts of assets, longitudinal assets, treatment, and we collect lots of data, but still, I don't think we have big data in the water sector, or not yet. And we struggle with quality of data. And what Jackie was presenting, that Macau Water went all the way from digitalization and knocking on the door of AI applications. And that, for me, really gives an idea where the water sector in general is. That the water sector is dealing with a limited amount of high quality data. And I can see the movement to collect data in non-traditional ways. For example, video analysis of videos to give us a bit more data that we can use in decision making. But what I see in general with AI applications is that we are slowly moving from pilots, because the water industry is well known for piloting, but very cautiously moving from pilots to scaling up applications. And AI is a good example of that, because we don't see huge scaling up in this case. The other thing that I'd like to mention is this infrastructure related, obviously, to data quality, sensor networks, and most importantly, interoperability, because different providers may not provide the data or sensors so they can talk to each other, elements of this system. And recently, again, and I'm talking about global perspective, there is this issue of balance between large cloud-based models, and we know that the data centers and cloud centers require lots of water and lots of energy. So balance between using cloud solutions to local, low carbon or low water usage, cost-efficient AI solutions. So that's another area of interest, I think, and it was touched upon, I think, by our speakers. Another kind of pillar of that AI application and scaling up of AI applications in the water sector is also the governance framework, or what kind of frameworks do we need to ensure AI-driven decisions remain still transparent, auditable, because I think the worry among the public, among the people, is that, oh, we will be run by these systems, AI will control everything. So how can we bring still human in the loop? And I think human in the loop is very important, particularly important for the water sector, where public health is at stake. And I think we've been talking quite a lot of time in the water sector about moving from reactive asset management to proactive management and catchment scale management and optimization, rather than small kind of local optimization. And finally, I wouldn't be able to talk about AI without mentioning that the water sector is slowly losing that human expertise through people retiring, moving away, and the AI is coming in. So what kind of organizational changes do we need within the water sector to fully benefit from AI-enabled workflows? So for me, when I listened to these presentations today, they were so impressive. I've seen catchment-based management. I've seen asset management. I've seen AI kind of getting into water utilities. But I think we should be addressing all of those kind of questions that I've raised in terms of the global situation with AI and water management. I hope I addressed your question appropriately.
Thank you very much, Dragan. This is excellent. I think what you have said touch upon some of the points the presenters also shown today. So maybe do you have any questions to the speakers at the moment?
Well, I would imagine it would be interesting to see their opinion about some of those issues. For example, are we now moving more to kind of scaling up, or are we still prototyping? And I think that would be the question for each of those, because they all operate in a slightly different situation as provider, as developer, and some utility.
Okay, maybe let's start from Jackie. Are you ready to upscale?
Yes, I'm quite agree about what Dragan just mentions about the data. The data, I mean, the data is the most important, and we have experience, I mean, before, and we spend a lot of times, several years, trying to have something like a very fundamental, I mean, cleaning and management, and have a very standardized for those data managements. And I have experience, I mean, in mainland China, I've been quite a few of water company in mainland China. And I also find that, the IoT, the sensor is not a matter at all, From the time being, the price is very reasonable. To install, the cost is not an issue. But the data management, sometimes they deploy a few thousands DMA, lot of pressure sensor, lot of flow meter sensors, etc. But the point is how to manage, how you get use of those data, how you can dip it down, to deep down to analysis. This is the real important. And I very agreed about what Jagan just mentioned about the people. We have to have people well trained, trying to have at least they know the operations. They understand all the things, and then they can make the decisions. Even if we have AI, the application is very powerful. But if you rubbish in, rubbish out, something like this. So you have to have something like a well planned, well developed, and well trained people. And data management, is very, very critical. I suppose, yeah. So yeah, we built. So that's why I mentioned from about since 10 years ago, we create. I can share some of our experience. We create divisions in Macau Water called resource management divisions. It's purely data management. It's not IT department, not IS department. It's operation department. Within the operation department, you have to handle your data yourself. You understand what's the operations you have handled, and then since 10 years ago, we create such divisions, and it works very well. It works very good. So that's why we can create such something like a data visualization platform. All operational data are inside, and we use it every day. So I think this is my comment about that. Okay.
Thank you,
Thank you,
Jackie.
Dawn. Yeah.
Chu Wan, what do you think?
Yeah, when we're talking about the data, especially in each kind of a scenario in water industrial, and that is not a new issue. And we all know about the rubbish in, rubbish outs. But as all we know that, especially in China, not only water industrial, each kind of industrial embrace the AI now. Now we're looking into the data, the high quality database. And I think that we need to, at least we are able to do two kind of things. The first one, it is we have to sort it out. What kind of high qualified scenarios for the water industrial? And then we can try to define what kind of a high quality data. And based on these two steps, and we can try to collect very good qualified data, and then to push the AI agents to come to the autonomous control. So that is my point of view in this AI agents era, how to deal with our data in the water industry.
Thank you, Chu Wan. And Rezhu?
I'm totally agree with all of you that inaccurate data will hold back the development of AI in our industry. Because my background is water resources engineering, so I know that if the business process aren't sorted out, the IT and AI tools won't just work. So I think we will build step by step on three foundations. They are data, scenarios, and models. And the core principle is start from the business and return to the business. The data must come from the real assets and operations. And the scenarios must focus on the most painful and cost-effective problems, and models must solve specific business decisions. Only when the three work together and they actually deliver. That's my opinion. Thank you.
Thank you, Roju. I think most of you are focusing on the data and data quality. So I would like to ask Dragan again. So what's your feedback to the answers from the speakers?
Yeah, I think this is quite often the discussion that we have when we talk about AI and modeling in general. That the quality of the data that we have in the water sector, it's not always at the highest level and takes a lot of time cleaning the data, removing the outliers, or making sure, and also creating metadata information about data. Maybe I should move to another, if I'm allowed, Dr. Lee.
Yes, please.
Maybe another question, because in the water sector, we are also struggling to attract people to come and work in the sector. And I find that AI is an attractive topic to bring people into the sector and maybe teach them about water rather than the other way around. So do you see that issue in terms of getting people to get into this water and AI sector, and how easy is to recruit early career people to come to work in the water sector?
Thanks, Dragan. Anyone wants to start first? It's very much linking to this skills, workforce, yeah.
I think you may need to name somebody.
Let me try first, because
Oh,
our
good.
industry is a little profit. So I think the business people need to embrace AI and go through their own transformation. That's all.
Thanks. Chuan.
Actually, I didn't come up with a very good answer now, but talking to the how to say, the talents or human resources in the water industry, how to say, the many situation we face now, especially we work with the water sector, we note it is not easy. It's quite difficult to find a very talented people who can know a lot about the water scenario and also know about AI. But how to say, that's quite difficult. But I think that when we come to the physical scenarios, we can find ways. If we would love to use the AI to accelerate our water industry. And from my point of view, our Baidu's experience, how to say, we have to collect all the human resource in the same scenarios and just based on our IT infrastructure, and we just based on these scenarios, we can push the talented from environmental engineering or the water conservancy or water resources engineering and the IT engineerings come together to figure out one scenario to figure out one cases. And I have no idea if it is a very feasible way, but I think that we just come together to make some good cases. I think that we can try to conclude a feasible way for the water sector and water corporations, and we will find ways.
Thank you. It's also about collaborations. Thanks. Jackie.
Yes, and I think this is always very challenging. I mean, to get some young engineer, or especially those AI engineer, into water sector. As as I think everybody knows that water sector is kind of a traditional industrial, especially in Asia. It's not easy. I mean, for hiring such a IT guy or some very experienced or AI expert, I mean, to this sector. We also encounter these issues, but what we are trying to do is we will hire very fresh engineer, and then we trying to train it up ourselves, because as we just mentioned, that the practical experience is very critical. So if we have learned that, I mean, the young engineer, I mean, they learn the practical experience and operational experience, and if the AI development, I assume that the AI development is very fast and very rapidly. So if they learn the technical skills, and then just now Dr. Wang talked about, if we can get use of those AI tools or AI's development, and that will be very efficient and very good, I mean, for our staff. Yeah.
Thank you.
Yeah, I've seen that in various places where, as you say, you get somebody who is trained either in IT or in water, and then you train them in the other area so they can kind of use both skills. And although there are some organizations now that try to train people in hydroinformatics area, which involves, I think, both. So that was kind of very interesting. There were questions, I think, Hong, in Q&A session, and one was related to agents, and I didn't mention it in my summary, but that is where I see quite a lot of activities on the research side. Lots of people are. I have a PhD student who is doing quite a lot of work, very interesting work in that area, but we are not the only one. Lots of, as I say, scientists are looking into it. And the question was, from an industrial perspective, how do you define an agent in the water sector? And I would end on that topic. I will connect this human in the loop, because we want agents, yes, to be acting on information, to invoke tools, simulation, optimization tools, to present results, analyze the results, and present it to us. But how do you ensure that there is transparency, accountability, and that a human still can have an oversight of those agents? Anybody?
Thank you, Dragan. Yes, I think Chuan, and you should give some comments on this as well.
Yeah, but thanks for that. Thanks for that question. It's really, how to say, thoughtful. And I would say that talking about the AI agents, we need to make some definition, especially in the past week, past few days, and China governments give some definition about what it is AI agents, what AI agent can make its function in several kind of scenarios, and China government gives some advice. And from my point of view, for the definition, I think that the the agent shall cover about the in our water industry. It has to have some knowledge. That is the first key parts, and the second part, it is they need to the AI agent needs to have some capability of analyze. And the third part, it is they need to do some decision making. And the fourth part, it is they need to do some act. That is the closed loop. And as all we know that when we come to the AI agent era, and we just doubt about that if it is accountable, the data transparency, and do we have a data privacy? There were many kind of problems, especially when we come to the physical world, the real world. And I would say that for the foundation line, it is we need to keep it safe, not only in the AI cloud or in the how to say, or in one machine in the plant or water plants. We need to keep it safe, especially for the data. And the second thing we need to ensure, trying to ensure that the accountability. So now we use the large language model to do the how to say, to do the just like the smart engine, we call it smart agent engine, which can provide the task tackling and use the tool calling. And then we used our mechanism models to support the large language models to know about our scenario. For example, for the sewage treatment, for the sewage treatment, when we talking about the operation optimization in a sewage treatment, and especially for the large language model, only the large language models has no capability of how to deal with the narration, how to make the smart dosing, but the mechanism algorithm can help the large language models to know about the scenario. And then when the large language model and mechanism model combine together, they can do the collaboration to make a decision making and then give a very good decision making and come to the SCADA system. And as all we know that, especially in China now, for the how to say, waterworks or sewage treatment plant and water treatment plants, we all have some good cases that AI can dominate the control, especially just accounted for the 95%. So I think that good case and can give a reliable infrastructure and give a reliable data, and then we just come to face the reality that maybe AI can one day help us to deal with some physical and complex scenarios. That's my answer.
Thank you, Chu-Wen. So I will have Jackie to answer one question about reducing capex during digital transformation and then AI integration. Just a few words.
Okay, I mean, for the AI integration with the smart water, what we are trying to do is to, for the asset management point of view, we are trying to have a good maintenance for the asset and have what we call preventive maintenance for those assets, and then that will largely reduce our capex for those investments. This is one point. And for the other one is for the network management, because if we can integrate with the AI and those smart solutions, we will have a very good pressure management, and this will prolong the lifetime of the networks, the age. So it ultimately, I mean, will reduce the capex investment.
Thank you. For Ruozhu, there is a question about mapping of assets. Do you have any? Do you have a few words about the asset mapping? I think that's for you, right? Mapping of assets.
That's a good question. We start by creating a digital chain of each asset, including its location, ID, and key attributes, and link it to a visual market or QR code and field. Then using AI device or mobile app The system recognizes the mark and overlays real-time asset information, metadata history, and work instruction onto the real-world view. That's our pace.
Thank you very much, and thank you all. This is the end of the Q&A discussion session. Let me ask Yifeng to give a summary of the webinar. Yifeng,
Okay, thank
please.
you. Yeah, thank you, Dr. Lee. Yeah, really, it's time is up. I think the discussion is really hot. I mean, quite a lot of questions in the QA sections. Yeah, let's wrap up. Let me thank all our speakers, Dr. Wang Qiuwan, Miss Shen Luozhu, and Jackie Lee, and our distinguished panelist, Professor Dragon Savage. And a special thanks to all of you, the audience, for your engagement and thoughtful questions. Given the rapid pace of the AI technology evolutions, what we are seeing today may be just a start point of a much longer journey. The IWA Digital Water Programs China subgroup will continue to facilitate these conversations. Please stay connected through IWA channels for upcoming events and resources. Thank all of you again for joining us this evening. Let's keep advancing digital water together. Thank you. Bye-bye.
Bye-bye.
Thank you. Bye-bye. Bye-bye.
Bye-bye.
Thank you,
Thank
Yifeng.
you.
Before closing, I would like to share with you a few upcoming events of IWA. So we will have another webinar soon on 13th tomorrow on advancing N2O quantification towards mitigation insights from France. And then we have another webinar on the 19th May on emerging advanced oxidation and reduction processes for water treatment. And one of the top events on leading edge technology conference will be held in Texas, US from 1 to 5 June 2026. And of course, the most important World Water Congress exhibition to be held in Glasgow, UK from 4th to 8th October 2026. Last but not least, this is very much linking to all of us here. It's Digital Water Summit. It's an international summit to be held on the 24th to 26th November 2026 and in Turkey. And of course, I would also like to invite you to join the IWA Digital Water China subgroup Innovation Summit on the 9th of June in Shanghai. And for all of you, if you want to join IWA as members, if you are not yet IWA member, with this webinar, you can use this discount code to enjoy 20% of the discount. Thank you all. And this is the end of the webinar. Thank you very much.
Thank you.
Thank you very
Thank
much.
you.
Thank you.
Bye.
Thank you.
Goodbye.
Bye.
Bye-bye.